Hi, everyone. It's great to be here. I'm really excited to be a part of this. Today, I'm going to talk about the heterogeneity revolution coming to behavioral science. This is a set of arguments that we laid out in a paper just released last week. We'd love if you check it out and share it with your friends. In our paper, we described two twin trends that have come in behavioral science. Behavioral science, of course, is a field of behavioral economics, cognitive psychology, social psychology that generally seeks to change human behavior in order to improve societal welfare. One trend is a crisis of confidence. The idea, originally described by Jonah Lehrer in his article, "The Truth Wears Off," arguing that scientific method leads to lots of findings that don't replicate or become less true over time. And there are a number of efforts to try to replicate findings, first in psychology, later in biology and other settings, find mixed evidence, and it's really spurred a kind of crisis in thinking about replication. At the same time, there's been a rather dramatic increase in enthusiasm for the use of behavioral science to improve social welfare. We went from one behavioral science unit in a government to two in around 2013 to now, I think most recent count is more than 360 governmental units using behavioral science to try to improve people's situations. What I want to put a finger on, though, is that there's a kind of inattention to heterogeneity of effects in both of these trends that seem at odds, and that actually can explain some of the issues that come from both of them. So on the kind of crisis of confidence, typically replication studies, so if an original author runs a study in, let's say, 200 people and another author runs a study in 2,000 people, the later replications are generally judged to be more robust because they have a larger sample, but there's very little regard for the qualities of the samples in the replications, where those people came from, how they might be different or not. And so failed replications or replications that have smaller effects end up being hard to interpret, and there becomes a kind of back and forth and kind of finger pointing that can happen in behavioral science, and we don't really learn as much as we could. On the widespread enthusiasm side, often cost-benefit analyses from promising early findings are based on the findings that came out of the early arbitrary samples, or maybe effects in small subgroups, including the paper I showed you on the previous page. But when those same solutions are tested in new situations with new populations, or even if the world changes, we typically don't see the same kinds of effect sizes later on, which then feeds back into this crisis of confidence. What we've argued in our paper is that heterogeneity and inattentiveness can mislead us in both of these ways. So if an initial study, so here on the x-axis is some moderator, or let's say a composite of a moderator that modifies how big the effect is. The y-axis is how large of a treatment effect you get. So it's the kind of theoretical difference between the treatment group and the control group for any behavioral treatment. An initial study might choose a sample where they think the effect's likely to occur, might find some promising evidence. Replication study, though, might say, well, the initial people didn't really describe which people were in their study, and they just said how many. So we'll just get more, and also not describe the people in our study. And they might find really small effects, and then conclude that, in fact, this result might have been a false positive, or perhaps the researchers lacked some kind of scientific integrity in their reporting of the results. We could avoid this problem, though, if we either had the whole population of effects or random samples of populations of effects. But it's exceedingly rare for experiments to even describe the sample they have. And actually, there are very few, if any, examples of population-based behavioral experiments that try to get the entire population or random samples of it. And this can lead to a heterogeneity naive hype cycle. So preliminary study in convenient arbitrary samples leads to lots of maybe news coverage and broad claims based on limited data sets. Later authors are kind of skeptical and run a large replication, but it's happening in equally arbitrary samples. And then there might end up being broad claims in the exact same news publications that science is broken or original authors were wrong and time to start over. This ends up, I think, being kind of wasteful. I think we abandon lots of good ideas that could work for important subgroups if only we would understand the conditions under which they've been discovered and how we might apply them to different populations. So when I saw that Amory Lovins was on the call, I pulled out my favorite quotation from him. I don't do problems, I do solutions. So this isn't just a finger wagging talk. I do want to offer a potential solution, which is to, as much as possible, conduct high quality behavioral experiments in generalizable or random samples to see the distributions of effects, and then use conservative methods, statistical methods, for finding subgroups. such as Bayesian causal forests. In one paper we had come out of Nature a couple years ago, we did this. We tested a very short intervention, about 30 minutes, 30 to 45 minutes, to change students' beliefs about their abilities to learn. This is 15-year-old in a national sample of US public schools. This is the first ever randomized trial conducted in a nationally representative sample of schools. And here what you see is you get larger effects of a very short treatment on students' grades when the school norms support students' mindsets. You don't get much at all when the schools are unsupportive, right? And the argument from the efficiency of science perspective is we kind of don't need 65 papers or responses written in Nature or PNAS saying that the effect either replicates or doesn't replicate. We also don't need the initial hype or the premature abandonment. Just conduct a study in a random sample and summarize the distribution of effects, and then try to understand where it holds and where it doesn't and why. Now, just to summarize, I think that an inattention to heterogeneity can explain much of the seeming crisis, not all, but much of it in the behavioral sciences. The best way to be attuned to heterogeneity, though, using generalizable samples and sophisticated modeling, is rather expensive and not accessible, which makes it quite rare. And so my closing thought is to argue that if we make investments in shared research infrastructure, as for instance, as new social programs are introduced and evaluated with investments after COVID, then scientists could stop being misled by heterogeneity and start leveraging it to develop better causal theories and more effective programs. We argue for this in more detail in this paper. We'd love it if you take a look and let us know what you think. Thank you very much.